All right, today we're going to finish up the second section, which is about distributions of data. There's not a ton of new information in the second half of this section. It's more about just being able to compare distributions well. So if we're going to compare two sets of data, we start by analyzing the shape, just like we did in the in the first part of the section, but we're going to do it for each distribution, for each data set. And then if they're symmetric, right, so if both distributions are symmetric, that's important. If they're both symmetric, then we can use the mean and the standard deviation to compare them, okay? If one or both of the distributions are skewed, so if one is symmetric and one is skewed, or if they're both skewed, we use the 5-number summary, the minimum, maximum, the median, and the first and second quartiles. So let's take a look at how this will work. You should have your graphing calculators with you, and you should be able to put this data into them and use the TI Inspire the way that we were doing in class. The instructions they're going to give on this PowerPoint are different because it's for a different kind of calculator, so make sure you're using the instructions that you have from class. So here we have Tyler and Jordan working through brain teasers on the computer, and we have two charts that record the amount of time it took them to complete each game. So use your graphing calculator, use your Inspire to create a histogram, and then we're going to describe the shape. So you'll probably have to pause to put the data in and make the histogram for each one. Your histogram should look something like this. They might look a little bit different on the Inspire depending on the scale of the window, but you should get that Tyler's distribution is positively skewed, so there's a tail kind of coming off to the positive side, and you should see that Jordan's histogram is symmetric. All right, if we look at part B, this time they want us to compare their distributions using the means and standard deviations or 5-number summaries. Since we already said that one is skewed and one is not skewed, we know that we're going to use the 5-number summaries. If even one of them is skewed, we use the 5-number summary. So I went ahead and did box and whisker plots for each of them so that we could see the 5-number summary a little bit. Tyler shows his minimum and maximum values up here. Here's the median. That's the one that's a little more symmetric. Jordan's is symmetric. In this one, it looks a little bit like it's not, but because the tails, or the whiskers, I guess we call them, are pretty even, and the median line is not exactly in the middle, but it's not super off. This one is actually symmetric, and this one is skewed because of the way that the whiskers look. It's not as obviously skewed in the box plot as it is on the histogram, but because this tail is a little bit longer, there is a little bit of a positive skew. It's not super easy to see with this scale, I don't think, that the box plot generator put on there for us, but technically that one is skewed and this one is symmetric. And so one distribution is symmetric, the other one is skewed. The median for both is 4.35. So it turns out that they both have the same median, but if you look at Tyler's times, if you look back at your histogram, 50% of his times are between 3.45 and 5.15, and 50% of Jordan's times are between 3.75 and 5.4. So Jordan's times have a smaller interquartile range. The interquartile range, which we often abbreviate as IQR, I take Q3 minus Q1. So Jordan has basically less space between his quartile 1 and quartile 3, so it might suggest that he was a little bit more consistent than Tyler was because Tyler's interquartile range was a little bit bigger. All right, so I want you guys to try this one. Again, use your graphing calculators to get the histograms, and then to get the mean and the standard deviation or the 5-number summary, depending on what you need. All right, your answer here should be B. Second period had a higher mean and a greater deviation. First period is a little more consistent. So these both should have come out pretty symmetric, meaning that you were comparing them with the mean and the standard deviation. Hopefully you remember from class how to find those on your calculator, and you could use them to make your analysis here. All right, example 4. This time we're going to compare with box and whisker plots instead of with histograms. So here we have the daily high temperatures for 20 days for two different cities, Clintonville and Stockton. So use your graphing calculator to do the box and whisker plot for each data set and describe the shape. All right, hopefully you did that. This is what the box plots looked like on a different calculator. Yours probably look a little bit different on the Inspire. But it looks like both distributions are symmetric. So that means that we're going to be able to compare them using the mean and the standard deviation. All right, so we already said since they're both symmetric, we're going to use mean and standard deviations to compare them. So let's take a look at how we would analyze this. It says the distributions are symmetric, so we're using mean and standard deviation. The mean, or the average temperature for Clintonville, is about 63.15 degrees, and its standard deviation is about 5.4 degrees. The mean temperature for the other city, Stockton, is lower a little bit, 63.05 degrees, but notice that the standard deviation is quite a bit lower, 1.76. So the averages are pretty close to the same. This one's a little bit lower, but the lower standard deviation for Stockton means that the temperatures here are more consistent. They don't vary as much, they don't range as much as the temperatures do in Clintonville. All right, so last one, I want you guys to do that same thing with this question. Get the box and whisker plot and then compare. All right, in this case, C was the best choice. The median number was 23 more, for baseball was 23 more than the median was for soccer. The distributions are skewed. You probably could have get more information that you might have written down, which is fine. Here you're just choosing from the options that they give you. But since the distributions were skewed, you should have used the 5-number summaries to compare. All right, that is the end of this section, kind of a short video, but I hope you got a chance to practice with your graphing calculator to make sure you know how to do those different things. Bring any questions you have to class.